Right, moving on. From last lesson, we did product rule and chain rule. We are looking at the last of the trio known as the quotient rule. So quotient rule, as you can imagine, quotient means divide. So quotient rule is a formula. So if y equals u over v, now we must have u in the numerator and v in the denominator, then dy by dx equal, remember last lesson I mentioned that both rules start from the v, okay, that's why I start using v in the product rule. Now quotient rule must start from the v, so it's v du over dx, so v du minus u dv by dx all over v squared. We call it v du minus u dv over v squared. What's product rule again? Okay, so pause the video, ask yourself, what's product rule? Okay, play. The product rule is v du plus u dv. Okay, so the difference is from a plus to a minus and all over v squared. That's why, if you remember, v du, the first one is always v du to begin with. That's easy to remember. Okay, right, we're going to use this today. So, example, given that y equals x times 2x plus 5, find dy by dx. We can see a fraction is dividing, so we can use quotient rule. Okay, so u is the numerator and v is the denominator, just the denominator, not 1 over, okay, because u over v, so v is the denominator. So du by dx, differentiate on both sides, is 1, dv by dx is 2. Thank God they're quite easy. So dy by dx, the final answer is, so let's read again, v times du minus u times dv all over v squared. If I simplify a little bit, okay, so dy by dx, keep writing left hand side, 2x plus 5 times 2x plus 5 in numerator, 2x plus 5 times 1 is 2x plus 5, minus the 2x in here, the 2x cancel out, so it's just 5. 5 over 2x plus 5 squared, and that's the answer, right? Now, maybe one of you smarties will be thinking, so can we not use product rule because we can write 2x plus 5 as power of minus 1? Yes, you can, okay? So this one we're trying to use. If you have a separate paper, if you've got space on the sheet, on the notes, you can try to do this. What about if we try to use the product rule instead? So how do we do that? Well, we're going to let y equals x times 2x plus 5 and minus 1. Let me challenge you to work it out. Using product rule, can you have a go at the question? Okay, pause the video, have a go. When you're ready for the answer, you can press play. Right, so product rule. So u is x and v is 2x plus 5 to the power of minus 1. du by dx is 1. dv by dx, chain rule. To differentiate power of minus 1, differentiate from the outside to the inside. Differentiating outside is take the power down. Power of minus 1 becomes minus 2. Times inside 2x plus 5 is 2. That gives you negative 2, 2x plus 5 to the power of minus 2. Right, using the product rule. What's the product rule again? V du, so v du plus u dv and we'll simplify that. So if I put the power of minus 1 back into a fraction, times 1 is just itself, minus in here, so I've got minus 2x over 2x plus 5 squared. If I combine them, both out of 2x plus 5 squared, then the first fraction is 2x plus 5, and the second fraction is minus 2x. You will see 5 over 2x plus 5 squared. Okay, and as you can see, the same answer. So which one should we use? Well, the rule of thumb is if you see a fraction, then use a quotient rule. It'll be easier. But if you prefer to use product rule, you can as well. Sometimes product rule will be harder to use in a fraction, but you can see both give you the same result. What if your answer in different form? Let's say in product rule. What if you leave it in like this? You live in this line in here. Would that be wrong? Well, if the question did not specify which form was the final form, you have to work it out. Then, you know, leaving it this form is perfectly fine. So both give you all the marks. So the mark scheme, you will see A1, okay, or A1 and then OE. OE means all equivalent. So if the mark scheme says like this, all equivalent means anything that could be simplified further down, okay, that will give you the full marks, because we know this one could be simplified further down to this one. So yeah, so as a marker, we'll know this will give you full marks as well. But if the question wants you to give in a specific way, for example, let's say the previous example in here, the question wants you to give in this specific term, this specific form, then you must rewrite it as this specific form. Okay. So for example, if this question, okay, the question wants you to, you must find dy by dx in the form of a over 2x plus 5 squared. Then you know you have to write in this format. Okay. So what this one I'm trying to say. You can use either quotient or product rule, but when you see a fraction, quotient rule. Okay, be good and use quotient rule. Okay, when you see a burger, eat it. When you see chips, eat it. When you see a fraction, quotient rule. Example, next one. A curve C with equation y equals sine x over e to the power of 2x has a stationary point. So by now, when you see stationary point, it's like when you see McDonald's, what do? You know it's about differentiation. You go into the McDonald's. So stationary point means dy by dx equals 0. Okay, it's a no-brainer. Okay, you see a discount, you see the KFC spicy wings discount, you go for it. Stationary point, dy by dx equals 0. Find the coordinates of P. So there we go. So we're told dy by dx equals 0. So first thing, it's time to differentiate. Fraction, quotient rule. So u equals sine x, v equals e to the power of 2x. Okay. So du by dx, differentiate on both sides. Differentiate sine x. Differentiating sine will give you cos. What about e to the power of 2x? Differentiate 2x is 2. So 2 times e to the power of 2x. Okay, use a quotient rule. Okay, quotient rule. So dy by dx equals quotient rule. V times du minus u times dv all over v squared. I was going to say vegan, but you know, as a meat lover, I would never say vegan is like against my rules. V squared. We know dy by dx equals 0, so we'll make it equal 0. The good thing is when it equals 0, the denominator, when you multiply to the right-hand side, it becomes 0. So we're left with just numerator. So I'm going to write e to the power of 2x cos x minus, do you remember that? I said the trick terms we usually write at the end of the term. So I'll write 2e 2x sine x equals 0. Because by rewriting sine x at the back, you don't need a bracket. So by not having a bracket, it's much easier for us to visualize what to do next. Right? Next one. In here, so what can we do? We need to solve this equation. Okay. To solve this equation, now I'll let you try. You can try to think about giving some answers. Well, one might be thinking, why don't we move this minus term to right hand side? Because sin x and cos x could potentially make a 10x. That's good. But however, they both have an e to the power of 2x term. So I would suggest you factorize it out first. Reason being is then we have e to the power of 2x equals 0 or cos x minus 2 sin x equals 0. So potentially you might have one extra answer in here, but you don't for this instance because e to the power of 2x equals 0 is a maths error. Because if you try to get rid of an e, you try ln on both sides. If you try ln on both sides, ln 0, put in a calculator, it gives you a maths error. So there's no solution in here. So there's no solution in here. Okay. Or if you don't want to do ln, you can think about e to the power of 2x. Remember, e to the power of 2x graph like this. You've got x equal at x equals 0. Oh, sorry, y equals 0. So y would never be 0. Therefore, no solution. Anyway, back to right hand side. We can now bring the 2x to the right hand side. 2 times x to the right hand side. Divide both sides by cos x to make a 10. So divide both sides by cos x. So cos x divided by cos x 1. 2 sin x over cos x, make it 10. So divide 2 over, so a half equals 10x. So then we can inverse 10. So 10x, so sorry, hang on. X equals inverse 10 over half. So if you do arc10 over half in the calculator, it's in radians degrees. Radians. The range is, sorry, the domain is from 0 to pi. So when you do inverse a half, you get 0.464. 0.464. The other answer for 10 is here, but only from 0 to pi. Therefore, this is not required. So x equals 0.464, but we also need the coordinates. To find the coordinates, we need the y value. So y value, we're going to sub into the y equation. A lot of students will get confused which equation to sub into because you've got so many things you've written here. Which one do you sub in? Ask yourself the question, what do I need? McDonald's? No, I need the y value. So I need the y value, I sub into the y equation. Okay, if I want a derivative, if I want to find a gradient, I sub into the derivative. I want the y value, y equation. Gradient, the gradient equation. Simple as that. So I need a y equation, so I'm just sub into y. So y equals sin x over e to the power 2x. So y equal to so sub into, sorry, got a brain fart. So let me sin x. So sin 0.464 over e to the power 2x, 0.464. Put in a calculator, you will get 0.177. Therefore, the stationary point is 0.464 and 0.177. All right. If you're happy with this, now, to be honest, the second part of the question, this question example, is nothing to do with quotient rule. It's more about basic differentiation, about some concepts about stationary point being dy by dx equals 0. So if you're happy with this, have a go at this question. Okay, pause the video, have a go in part A first. When you're done in part A, you can have a go at part B. I'll give you the answer part A first. So pause the video, have a go at part A. Okay, when you're ready for the answer, you can press play. So the answer to the part A is 2 pi over 9. So x equals 2 pi over 9. Okay, if you got it right, then move on. Okay, then move on. I'll pause the video. Okay, then have a go at the question in part B. I'll give you the answer in part B as well. B actually should equals to y equals a third x. So if you got both of them right, well done. End of lesson for you. Okay. Oh, actually, not yet. If you got it right, then what I'll ask you to do is next page you should see as blank page. You should see a summary of chain product and quotient. So in here, maybe write a little summary of your own. I'm not going to check it. How do you work out chain rule? Maybe give yourself a small example. How do you work out product rule? Give yourself a small example. Same with quotient rule. Okay, so this page, if you need to look back on chain product quotient, this is your page to go to. Okay, right? You could be as creative as you want. So once you finish, that's the end of the lesson for you. Now let's go back to the exam practice. For those who didn't get part A correct, let's go through. Find x coordinate of a turning point. Turning point means dy by dx equals 0. Now, I'm not sure if you realize I actually made a mistake in here because this exam practice was meant to be in the product rule chapter rather than the quotient rule chapter. Right, regardless, let's go through. So to differentiate, so we see a product, so we use product rule. So E equals x root 3 and V equals to sine 3x. Let's differentiate. du by dx, differentiate e to the power x root 3 looks complicated, but it's not, because root 3 is the coefficient of x. It's like differentiating 5x. What's the derivative of e to the power 5x? 5 e to the power 5x. So same in here is root 3 e to the power x root 3. dv by dx, differentiating sine 3x is 3 cos 3x. So then we can use the result formula, product rule. What's the product rule? v du plus u dv. So v times du plus u times dv. And we know that equals 0. So what can we do in here? Well, both terms as e to the power of x root 3. So maybe we can factorize it out. So e to the power of x root 3 bracket. So we've got root 3 sine 3x. The first term. Second term, we're left with 3 cos 3x, 0. So therefore, e to the power of x root 3. Actually, why do I keep? I don't have right now. I can go on the left side now. So e to the power of x root 3 equals 0, or root 3 sine 3x plus 3 cos 3x equals 0. Now you can pause at any time. You've got made a mistake. You found your mistake already. You can pause anytime. That's a good thing about the video. You can pause anytime and correct your mistake and play the video again. Okay. Right. I'm going to carry on. The left hand side is no solution. I'm still going to put a reject in here. Right hand side, I'm going to bring the 3 cos 3x to right hand side. Reason being is I know sine 3x and cos 3x can make a 10 somehow. So minus 3 cos 3x. Next, I'm going to divide both sides by cos 3x. And that will give me root 3 tan 3x, because sine 3x over cos 3x is tan 3x. On the right hand side, you get negative 3. Divide the root 3 over. Okay. Then you have, if I do this, inverse tan in the calculator of negative 3 over root 3, I get a negative a third pi. So negative a third pi. Be careful with it because you might need class diagram. The other answer that 10 is negative is here. So negative third pi, if you go in here, that's pi minus third pi, which is 2 pi over 3, or 2 pi minus the third pi, which is 5 pi over 6. If I divide everything by 3, then x equals negative pi over 9, 2 pi over 9, or 5 pi over 18. We're told x is between minus pi over 3 and pi over 3. X is between pi over 3 and minus pi over 3. So it's minus pi over 3 out of the range. Now I hate this. Minus pi over 3 in calculator. Pi over 3 in calculator is 1.04. So minus 1.04. That means the range is between minus 1.04 to 1.04. What's minus pi over 9? Minus 0.34. Yep. Oh, actually, if you look at the question, we know p is only positive x. Therefore, we can't have this. So 2 pi over 9. There we go. So what about negative pi over 9? Negative pi over 9 is here. It's not required. That's how we know. Okay, so right. So that's how we got x equals 2 pi over 9. That's the answer, part A. Part B. Find an equation of the normal. So if you're happy with it, pause the video, have a go at part B. Okay. Find an equation of a normal to part C to the point where x is 0. Equation of normal. Bring us back to year 12. Equation of normal. To find the equation of normal, you can either use y minus y1 equals mx minus x1, or some of you prefer the old school, y equals mx plus c. Both of them fine, but what you both need from these two is the m, which is a gradient, and you also need a point. Okay, and this gradient has to be negative 1 over as well, the negative reciprocal. Reason being is a normal equation of normal. Gradient of normal. Right. So have we got a point? We've got x equals 0, but that's not enough. So point is 0 something. So we've got some work to do. So let's work out the gradient. Okay. So work out the gradient, I need to use the gradient function. We know the gradient function, which is here. So to find normal, so that's the first thing we do. Okay, so to find normal, to find gradient. Okay, we're going to use dy by dx, because dy by dx gives you the gradient. So dy by dx, okay. So dy by dx, I'm going to rewrite the derivative again, is root 3 e to the power of x root 3 cos sine 3x, root 3 e to the power of x root 3 sine 3x, plus 3 e to the power of x root 3 cos 3x. So when x equals 0, dy by dx, you sub it in here, in there, you should get minus a third, if I'm not mistaken. Oh no, actually, you should get 3. So you should get 3. So that this is the gradient. So this is the gradient of tangent. So therefore, the gradient m normal equals negative a third, negative reciprocal. The next thing we need is a point. When x is 0, so we need a point when x is 0. To find a y equation, we plug into y. So y equals e to the power x root 3 sine 3x. Put it in a calculator, you get 0 as well. So we've got a point, we've got a gradient. Now we can use the equation. So y minus y1 equals mx minus x1. Or if you prefer, y equals mx plus c. So 0 equals minus a third times 0 plus c. C equals 0. And then on the left-hand side here, you quickly get y equals negative third x. So y equals minus third x plus 0. So you can see both of them give you the right answer. Okay, so that's the end of the quotient rule. Same with you guys. Write down a summary for chain product and quotient. All right, and that's sort of a little end of product, quotient and chain rule. Now from now on, we're going to use these 3 rules quite frequent. Depends on the question. You need to be able to use it quite flexibly between these 3. Okay, and that's the end of today's lesson.